All right, guys, I hope you're excited to learn some math today. We're going to be doing more on logarithms, and today we're going to be looking at some properties of logs. Now, guys, in the past, in other years, we have always derived these, which means to start with a property of exponents and then come up with these properties of logs by rearranging into logarithmic form. In the interest of keeping this video short, I'm not going to. However, if you are interested in this, feel free to ask and I can show you where these come from. Let's look at these properties that are always going to be true no matter what log we do. The first one is that log base b of b is always going to equal, and this is one you can just see, log base b of b is always going to equal 1. This is asking b to what exponent gives you b. And so, b to the 1 power gets you b, So this is the answer to a logarithm, is what exponent needs to go on the base. So what exponent needs to go here to get to here? And the answer is 1. An example would be, log base 3 of 3 would equal 1 because 3 to the 1 power equals 3. So that one should make sense. All right, our second one, log base b of 1. When I'm saying b here, it means it doesn't matter what base. This is what makes it a property, is it doesn't matter what base it is. Log base b of 1 will always have the same answer. And what is that? Hopefully we know it is 0, because again, this is saying b to what power will give you 1. And anything to the 0 power is 1. So that's the exponent we need to put on b to get to 1 is 0. So, for example, log base 73 of 1, it doesn't matter what the base is 0. 73 to the 0 power is 1. Okay. Our third property, log base anything of 1 over that thing is going to equal, and I hope you can just figure this one out. What is it going to equal? B to what power gets you 1 over b? Well, to divide, we need a negative exponent. And in this case, it's just the negative 1 power. B to the negative 1 power gets you 1 over b. It doesn't matter what the log is. So this is saying b to what power gets you 1 over b. And again, that answer is negative 1. B to the negative 1 power. Negative exponent tells you to divide. If you're not sure about this, you might want to go back and do lesson 7.3 if you haven't finished that yet. So I'll do an interesting one here. Log of 1/10. Now, you should have noticed that the base here is 10. When you don't write a base for log, it is automatically base 10. This is the same as if I had written log base 10 of 1/10. You don't have to write base 10 if that's the base. And so this is log base 10 of 1 over 10, and we need a negative 1 exponent to go there. Property number 4. Property number 4. And this is where we start getting into some ones that aren't quite so obvious. Log base b of x times y. So you can have any base log, and if you have two things multiplying, we can split this up into log base b of x plus log base b of y. Now, this goes both directions. Sometimes this is called expanding. So expanding into more than one logarithm. So you take a single logarithm that's multiplying and you can split it up into two different logs that are adding. Or sometimes you have two logs that you actually want to get together, and that's called condensing or combining. Condensing, or sometimes we call it combining, either way. And so let's look at two examples here. Let's say we have, let's do log base 3 of 18. Now, this doesn't look like it's multiplying, but I am actually going to show you that we can split up 18 in a cool way. We can split it up into log base 3 of 9 times 2. Now, this is useful because I can split this into two logs that are adding. Log base 3 of 9 plus log base 3 of 2. This is log base 3 of 9 plus log base 3 of 2. And log base 3 of 9 is one that I can evaluate. This I would have just had to have estimated. We talked about estimating. 3 squared is 9, 3 to the third power is 27. So this is somewhere in between 2 and 3. But I don't know exactly what number it is. But now I can actually do log base 3 of 9. 3 to what power gets me 9? Well, that's 2. And then this one can't be simplified, but I know since it gets smaller, it's going to be a fraction. It's going to be some sort of root that gets me down. And so this number will be less than 1. Nonetheless, we can just leave it like this. This is considered the simplified answer. Now, I just want to show you, you could have split this up into a different way. Like, let's say you split it into log base 3 of, like you've completely factored it. 3 times 3 times 2. 3 times 3 is 9, times 2 is 18. And if you factor it completely, this is what you would always get. Now, this is 3 things multiplying together. We can split this up into 3 logs that are adding. Log base 3 of 3 plus log base 3 of 3 plus log base 3 of 2. Each one of these becomes a separate log. And notice, I can evaluate this. Log base 3 of 3 is 1. Log base 3 of 3 is 1. And then this one can't be simplified, and so we leave it like this. And when we combine 1 plus 1, we'll get the same answer we got before. So that's one thing we might want to do is we might want to expand it. There's another thing we can do, which is we can combine. So we can do something like log base 6 of 2 plus log base 6 of 18. And this is going the other direction. Here we have 2 logs adding, and we can combine them into a single log. When you combine 2 logs that are adding, the base stays the same, log base 6, and the insides multiply. So this is 2 times 18. And we can simplify. 2 times 18 is 36. And sometimes, we couldn't do log base 6 of 2. There's no way to evaluate this. You can't do log base 6 of 18. Some people might think 3. Don't think it. It's wrong. 6 to the third power would be 216. And the answer to a log is saying what exponent it should be. So it's definitely not 3 here. But we can evaluate this one. What is log base 6 of 36? Well, 6 to what power gets us 36? The answer is 2. 6 squared is 36. So by combining it, we were able to simplify. Sometimes these just end up having weird fractions, right? Or weird things like log, I'll do natural log this time. Natural log of x, y, z. This is a log with a base of e, but we're just going to write ln. And the way we read it is natural log, the natural log of x, y, z. These are multiplying together. X, y, z is multiplying together. And so what does this split up into? Well, it's natural log of x plus natural log of y plus natural log of z, because things that are multiplying inside of a log can split up into adding outside of a log. Hopefully we feel comfortable about that. I'll let you try a couple here to make sure we are good. All right, property number 5. Putting all the properties in green. Property number 5. By the way, this is related to a property of exponents. I just want to briefly say this. A to the x times a to the y. When you multiply exponents with the same base, you can add the exponents. So logs, when there's logs with multiplying, it can go to adding. Okay. Similarly, when there's exponents up here that are dividing with the same base, you subtract the exponents. And there's going to be a similar thing with logs that relates dividing with subtracting. If we have log base anything of x over y, this can be split up into, I want you to predict to yourself, what do you think it will split up into? Well, just like in exponentials, there's a relationship between dividing and subtracting. It's the same in logarithms. Log base b of x over y is log base b of x minus log base b of y. So you subtract, if there are 2 things inside of a log subtracting or dividing, you can split it up into 2 different logs that are individually individually subtracting. Let me show you a cool thing we can do here. Let's say we have log base 2 of 4 over x. Okay, so I've got a log with a base and it's dividing. What log should this split up into? Well, hopefully we know it's log base 2 of 4 minus log base 2 of x. And we always want to be on the lookout once we've done something with it. Can we simplify a little bit? And the answer is yes, we can do log base 2 of 4. Log base 2 of 4 is 2. And so we'll see in our next class that if we're graphing this, if this was y equals this, we could rearrange it and make it be negative log base 2 of x plus 2. And now we can see this is just like transformations of a parent function, whereas this one is like kind of nuts. And so by rearranging it, we can actually graph things. I will give you an example that comes up. This will come up if you're in AP Calculus in 2 years. This is a problem that actually came from the AP exam. Part of the answer ended up having log, I forgot what the base was. Oh, it was natural log. It was natural log of 14 minus natural log of 6. And this is not, so it was a multiple choice question. And even though the students correctly got natural log of 14 minus natural log of 6, some kids didn't know what to do with this. So what should you do with this? I'll give you the multiple choice answers from that AP exam. And I hope you notice what's going on here is that these are two subtracting logs with the same base. They're both base e because it's natural log. So it's natural log of, we can combine them into a single log. So sometimes we want to take a fraction and expand it. Sometimes we want to take two separate logs and combine them. And here it's 14 divided by 6. And this can actually be simplified because it's a fraction that we can divide by 2 over 2, and we get natural log of 7/3. And that's how the multiple choice answer was left. So if you don't know your properties of logs, you're never going to guess that natural log of 14 minus natural log of 6 is natural log of 7/3. I mean, where on earth is that coming from? But, if you know your properties of logs, then it's quite easy to get. So I'll let you practice a couple of these. And let's go to property number 6. This is always my favorite property. It comes up a lot. Log base b of x to any power. If there's an exponential inside of a log, you are allowed to take that exponent that's on top of the argument and move it as a coefficient in front that is multiplying. So it's a way of turning exponentials into multiplying. This is going to equal log base b of x. So you can take an exponent and move it to the front. Or alternatively, if there's a number multiplying outside of a log, you can put it as an exponent inside. Let's do a couple examples of how this might look. So let's say we have, let's do log base 3 of x cubed plus log base 3 of x to the 5th power. What can we do here? Well, one thing we can do is we can move the 3 in front. There's actually a number of things we could do here, but I just want to show you one thing we can do. We can move the 3 to the front, 3 log base 3 of x, and we can move the 5 to the front. This would be 5 log base 3 of x. And these are now this exact same thing. These are like terms. 3 of something plus 5 of something equals 8 of that thing. So we couldn't combine them before, but now we can combine them into just a single log. Alternatively, I want to show you a different way you could have done this. You might have noticed that these are two logs adding. And so maybe you wanted to use property number 4 that says if you are adding two things, you can combine them into something multiplying. Watch how this would go. This is log base 3 of x cubed times x to the 5th. And you should know from your properties of exponents that if you have two exponentials that are multiplying, what is this equal to? Well, you can combine this into log base 3 of x to the 8th. When you multiply, you add the exponents. And if you wanted to now, there's just a single log with an exponent, you could move this to the front and get this. Or if you got to this one and you wanted to move the 8 inside of it, you would get this one. And so sometimes there's more than one way you can go about doing something, and it ends up being quite nice. So before we move on any further, I'd like to practice some mixed ones here and kind of go over it. Let's look at, oh, you know what? Sorry, I want to do one more example of this, because this is kind of interesting. It may not look like it right away that this is this property. I should have done this in blue, sorry. But check this out. What if we have 1/2 log base 5 of 49, okay? Well, 1/2 is multiplying times log base 5 of 49, and so we can move this to the front, sorry, we can move this to the exponent, and it'll be log base 5 of 49 to the 1/2 power. Now, guys, what is 49 to the 1/2 power? Well, I hope we know that anything to a fraction power is a root. This is the square root of 49. And so square root of 49 is 7. So fraction powers are roots. And look how much nicer this answer is. Log base 5 of 7 versus log base 5 of 49. It's a much simplified answer, and so sometimes this can be quite nice. Okay, cool. So I wanted to show that. And also, you know, sometimes these are written slightly different. Sometimes these are written as like log base 5 of 49 divided by 2. There is, oh, I hope you guys could see that. Was that off the page the whole time? I sure hope not. Oh no. Guys, I really hope this wasn't off the page, but I wasn't looking at it. When there's a fraction of, when there's a coefficient of 1/2, that can become the power. And then 49 to the 1/2 power is a square root, and so we can do the square root. I hope this was on the page earlier. Sometimes this problem can be written like this, and there is no property of logs that says if you divide by a coefficient, what you do with it. But dividing by something is the same as multiplying by the reciprocal, and so then you can notice that it's a multiplying thing that can become the power. So if it's ever dividing by a constant, you can move it to a multiplying thing in the front. Okay. Let's see, we're gonna do 2 more properties. No, I wanna let you guys practice some mixed ones of these. This is sometimes what like your homework looks like. Let's do log base 3 of 9 over x to the 5th power. Now, this has multiple things within it, but I want you to try to simplify it. And hopefully you realize that the very first thing you can do is you cannot move this 5 to the outside. You can't do it because it's not the whole thing to the 5th. This is log base 3, but it is 2 things dividing by each other. So we can use the dividing property. This is log base 3 of 9 minus log base 3 of x to the 5th. And you'll notice now it's just something to the 5th, and that this can move to the front. So we can actually simplify log base 3 of 9. Log base 3 of 9 is 2. 3 squared is 9. And here we can move this 5 to the front. And this looks completely different than it looked at the beginning. And I just want to compare this to another example. Let's say it was log base 3 of 9 over x to the 5th power. Now, it's not just 2 things dividing. That's not what's going on. You can't split it into a subtracting yet because the whole thing is to the 5th power. Instead, since it's something to the 5th power, the property of logs we'd use is the one that moves the exponent to the front. So the order matters. In this one, you had to do the dividing thing first because it's 2 things dividing each other. Here, it's not just 2 things dividing each other because those 2 things that are dividing are to a power. You have to do the power one first. And so this is 5 log base 3 of 9 over x. And now you can do the subtracting one. This is 2 things that are dividing, subtract. So this is going to be 5 times. Now this is going to split into a binomial. We need a parentheses on the outside. This 5 will multiply times both of these. 5 times log base 3 of 9 minus log base 3 of x. And this 5 will multiply times both. So 5 times log base 3 of 9 is 2. 3 squared is 9. And this one can't be simplified, so it's just 5 log base 3 of x. And so we get 10 minus 5 log base 3 of x. It does not come out the same way. Now, I'd just like to point out that this should make sense, right? This 5 went with both of these. And so yeah, the 5 ends up going with both of these. It ends up distributing. Here, the 5 was only with the x, so the 5 only ended up going with this one, right? So it should make some sense. Okay, let's do one more. No, I think that's, I'll let you guys practice some of those. And then let's do a combining one. Let's do 3 log base x of a plus 5, oh man, I don't, 15 log base x of b. Okay, sorry, you guys can't see this. Okay, so we're gonna do this, and we want to combine them into a single logarithm. Now, I see adding, but I can't just add them yet because there's no property that says if you have a coefficient in front, what you're supposed to do with that with adding. Instead, I need to deal with this coefficient first before I can combine them. So these coefficients become exponents. Log base x of a cubed plus log base x of b to the 15th. And now I have 2 logs that are just adding together. Log base x of something plus log base x of something, and these can combine into what? Well, hopefully we know it's log base x of a to the 3rd, b to the 15th. These are multiplying together. So if you have 2 logs adding, you can combine them into a single log that is multiplying.